I know. It's been a long time ever since I uploaded last video. Don't scold me saying you come and do few videos and you just vanished and you come back again later with some excuse. No, as I told you in the last video, I was starting a new project. This kind of a project we're starting from the scratch, so I had to do a lot of things like forming a team and working on the new tech stacks and so many things. So fortunately I found a tech lead. So one tech lead onboarded to my project, so I can share my load with her. So that means I might get opportunity to talk to you again. So thanks to her, let's talk a few more topics. Okay, so what we are going to discuss, these are the topics you must know if you are a full stack developer, because most of full stack developers switching from Java, either from .NET, and then they grow up with Angular, Node and all other frameworks. But you may be a good Angular developer, you may be a good Node.js developer, but I'm pretty sure you may miss at least one of these fundamental things you must know, right? So this video will be short and sweet and with full of information. So don't miss. Subscribe if you're not subscribed yet, and if you think this video is worth, just please share with your friends and audience who else might interesting. Okay, so first thing is first, if you take JavaScript, all of you have written at least one JavaScript in your life, right? If you're a programmer, of course you have written at least one JavaScript, at least just one console log at least, right? But how JavaScript works, if you're a Java developer, you know Java has something called JVM, and JVM has things called heap, stack and so on and so forth. But how JavaScript works, JavaScript basically was a browser based language, and it was supposed to run on a browser, not anymore, but how it was. It is a scripting language, not as a compiled full structured language as Java. But how this work? A lot of people don't know JavaScript also has a concept called heaps and stacks, right? But not same as what we know in Java, but doing almost similar thing. So let's discuss today how we can write a simple JavaScript, what is the smallest JavaScript program you can write, and also how JavaScript works. The smallest JavaScript program you can write is empty file with some JS extension, right? Extension doesn't matter, but what I mean, if you import some empty file into your HTML file, HTML page, that would be the shortest JavaScript program in the world, right? I'll explain why. So when JavaScript has a one very important component called JavaScript engine. So that is the what you compile your program and make into reality, right? So JavaScript engines work in two phases. One is creation phase. The second one is execution phase. If you run a JavaScript, or if your HTML page load a JavaScript and it execute with the two phases, one is a creation phase, one is a execution phase. The creation phase, it does three things, main three things, right? First one is creating an activation object. The activation object mean, in the creation phase, the first thing is creating an activation object. What it mean, it scan through your JavaScript code and it lists down all the variables and all the declarations. And the second one is creating a scope chain. The scope chain means it lists down and create all the variables which is in the current function. And the third one is trying to determine that this object, right? So most of people think this is always pointing to the Windows. It doesn't, right? So I'll explain the third one later, but let's see what are the first two things. Okay, so I have a sample JavaScript program, right? So you can see here it declares two variables, and then it has a function, and it has other two variables, and it executes the function. So what happens is, when the first time, right, in the very first time when these programs run, right, So it creates something like this, right? I'll show you this in practical in the browser, right? So it creates something like this, and we call this call stack, right? But this is not exactly call stack. Call stack is multiple things of this, right? So this is called execution context, right? It creates something called execution context. So this has two phases, as I said, right? This is creation phase, right? So this is the execution phase, right? So what the creation phase does is, if you take this particular program, right? So it will create A, right? And it will create B, right? So var A, var B, and then you can see there are two other variables here. See, ans and ans2. So it will create those two as well, right? I'll keep little space here because I have to do something else. Ans and ans2, right? But it will not create these two variables. It will not create these two variables or these two variables, right? So it's both same, right? So now why this area? Because since we have a function, this add function, so what it will do is it will create a variable from add function and it assign this function code here, right? So this entire function code will come here, right? So this is we call global execution context, or else otherwise it's a global scope, right? So we are going to learn something concept called hoisting in the next video, but till that don't focus that. So just think for now, if you have any variable or a function, right, not the function expressions, if you have any variable or a function in your script, in the creation phase, it take and create on the global scope. But see this one, right? So it will create this variable, but it will not proceed the assignment, right? It will not proceed the assignment. So this variable value would be undefined. This variable would be undefined, right? The function has a value. All these values would be undefined, right? So now it is in this line, right? So now what happens in the execution phase, right? It says A equal 10. Right? I'm going to run this program and show you this, right? And then B equal 20, right? So now in this line, what happens is we say ans equal add. We invoke the function. When we invoke the function, what happens is it will create other function scope here. We call it a function context. It's also similar like this, right? It also similar like this. So now what happened, right? So here you have a num1 and num2, say num1, num2, but those will undefined, right? So when it see the return, what happens is it will destroy this newly created stack, newly created context, and return the results of the context into wherever it's being called, right? So it means that this place. So now that means now ans would be, we pass 20 and 30, 10, it will be 30, right? I understand I'm not going to repeat these things, but you can rewind and see what I said, right? In summary, whenever we invoke a function, what happens is it will create a new function context, right? It will create a new execution context, and it will create all the variables, because all those three phases, right, again running in the this new function scope as well. Remember, JavaScript has a two-part creation phase and the execution phase. The creation phase has major three parts, right? So it create activation object, and it create the scope chain and determine this, right? So all those things will happen every time you create a function scope, right? For a moment, just think, right? For a moment, just think. So here within this function, right? For a moment, just think within this, sorry, not here, within this function, you invoke other function, right? So then what happens is, right, during this execution, it will create other functional, other execution context, right? If that function invoke other function, it will create other execution context, right? So you can see like that, every time you invoke a function, it create a new execution context, and every time you return, you call the return, it destroy this and come back to its parent, right? If you studied how Java works, how Java method execution work, how it creates a frame in the stack, this is the almost same way. So this is really cumbersome process. So therefore, we call this as a call stack, right? So therefore, we call this as a call stack, right? So how call stack works, right? In the so let's say here, right? Here in the first two lines, right? So you have a global execution context, right? So let me to change the color, right? So you have a global execution, So you have a global execution context, right? So now what happens is, when you invoke this add function here in this line, right? So let me erase all these things, right? So whenever you invoke this add function here in this line, right? So what happens is, in the call stack, it creates a new frame for the add, right? See, just imagine, right? Within the add function, I will show you this in practical, right? Within the add function here, you call other function called add2, right? So then what happens, it will execute another frame called add2, right? So now just think, you leave the add2, right? So if you leave the add2, what happens is, right, so the moment you leave the add2, right, so here what will happen is, add2 frame will destroy, right? It's a stack, you can pop, right? And when you leave this method, add method, and again it will remove the add as well, right? And after that it will go back to the global execution context, right? So we learned two things. One is execution context, another one is call stack, right? The call stack is nothing but who manage this execution context creations, right? But internally, this is how your execution context work, right? So now you will understand one concept, right? One problem JavaScript would face, right? This problem Java also facing this problem, right? So imagine this, right? So you have something like this. So you have a function, right? So add, right? So within that function, you call the add, right? You have a function add, within that function, you call the add. So now outside this, you invoke the add. So now what happens is, in the very first time, I'll draw this a little bigger, right? Very first time, it will invoke the add function. So that means it create new execution context here, right? So now within this function, because this is happening recurrently, so now this function, right? So this function invoke add again. So now we create new one. So now when you go back here, again when you come here, it invoke the add, right? And then this add will invoke this add again, right? So likewise, this will keep adding, keep creating frames, keep creating a context within the call stack, right? So what will happen is, when the stack is full, you will get stack overflow problem, or else you will get an error saying stack is full, or stack recursion is exceeded, right? So what's happening here, because you are invoking same function again and again and again, so as a result, it creating a context, it creating within the context, and it goes stuck, right? So in JavaScript in general, it has these values, because forget about JavaScript, any programming language, if you define a variable and a value, there has to be a place to keep these values, right? So we call this as a heaps, right? So heap is the place JavaScript keeping its variables and those values, right? And stack is the place where JavaScript creating a frames according to your method invocation, right? In the next video, I'm going to show you, right, in this within the browser. Next video, I'm going to upload tomorrow. So I'm going to show you this exact similar program and simulating the browser and practically visualize creating and disrupting this stack and context, right? So then, thank you very much. Subscribe and put a comment if you're interesting, and if you like, click on the thumbs up, and see you tomorrow. Stay safe, take care.